This is the third video in a series that shows how measure and capacity are taught in primary school. Here we will look at years 5 and 6, where they build on what they learnt in years 1 to 4, as well as being introduced to some new concepts such as multiplying and dividing by 10, 100 and 1000 to convert between units of length, mass and capacity, and also using formulas to work out area. So with measuring, children will continue to have lots of opportunity to measure practically with a high degree of accuracy using decimals that were introduced in year 4. They should continue to add and subtract measures using decimals, and they should continue to compare measures. Children will need to be confident in converting between units. For example, we have 150 millimetres, which needs to be converted to centimetres. So we can look at our diagram here, and in order to convert millimetres to centimetres, we divide by 10. So 150 divided by 10 equals 15 centimetres. And to show you another one, we've got 15 kilometres and we want to convert that to metres. So we multiply by 1000, we look at our table above, and 15 times 1000 equals 15,000 metres. Children are now introduced to imperial units for the first time, and they need to be confident converting between these two. Here are some of the ones that they need to know, and they might be asked a question like how many inches in 6.5 feet, or how many pounds in 9 stone. And I've just given you the answers here: 78 inches, and how many pounds in 9 stone? 126 pounds. Children recap on the difference between capacity and volume that they were taught in years 3 and 4, and focus on having lots of practical experience building solid shapes with centimetre cubes or bricks, and compare and order the volume of different shapes. And then they can estimate the volume of objects. Again, make it practical and fun to keep your child interested and engaged by estimating the volume of objects, say around the house, like it can be cereal boxes or a jigsaw puzzle, and get them to fill the containers with centimetre cubes or bricks to help them with their estimates. And then they can also do that for capacity by using water or rice to estimate how much different containers would need to fill them. Once children have had lots of practical experience, then they can use the formula for calculating the volume of cuboids, which is length times width times height. Building on what they were taught in year 4 by counting squares to work out the area of shapes that are rectilinear, they can now work out the area of shapes that are not regular by counting squares and using their knowledge of fractions to estimate how much of the square is covered to give an overall approximate area. So first they would count the whole squares, and the example here is approximately 37 squares. Then you have 6 half squares, which is the same as 3 whole squares. Then you have 1 square, which is about 3/4 filled. So the total area is approximately 37 plus 3 plus 3/4, which gives you an area of 40 3/4 centimetres squared. Children can also use squares to count the area of right-angled triangles, And this is an important step as it teaches them the relationship between the area of a triangle and the area of a rectangle or square, and why the area of a triangle formula is half times base times height. So we can see the area of this square is 25 centimetres squared by counting, and the area of the triangle is 12.5 or 12.5 centimetres squared by counting the whole squares and the 5 half squares. And we can see or check that if we put that into the formula half times base times height, which is the formula of the triangle, and we do half times 5 times 5, that gives us the answer of 12.5 centimetres squared. Now, just a note about formulas. Once children have had lots of experience of counting squares, can really see the relationship between that, then they can go on to using the more abstract formula. So the area of a rectangle is length times height. Area of a triangle is base times height divided by 2. The area of a parallelogram is base times height, and these are the key ones that they need to know. Lastly, children are also taught to calculate the area of compound shapes by splitting the complex shapes up in a way that it allows simpler areas to be calculated. So looking at our first example, we can work out the area of the rectangle, 3 feet times 1.5 feet, the height, and that equals 4.5 square feet. And then we can work out the two triangles, remembering that the area of a triangle is half times base times height, and the difference between the 5 feet base and the 3 feet top is 2 feet, which can be shared equally between the two triangles, giving them a base of 1. And we can put this into the formula. So this is 1 times 1.5 times 0.5, giving 0.7 square feet for each triangle. And then adding the 3 shapes gives 4.5 plus 0.75 plus 0.75, and the final answer is 6 square feet. To work out the area of the compound shape here, the second example, you would split the shape into a square and a rectangle as shown here, where I've labelled them A and B. The area of A will be 2 centimetres by 2 centimetres, which is 4 centimetres squared. And a second square or rectangle will be 3 times 5, giving 15 centimetres squared. And we can then add the two areas together to work out the total area of 19 centimetres squared. That takes us to the end of the videos covering measuring and capacity in primary schools. I hope you found them useful, and please check out my other videos covering maths and English. If you have any questions, please post them in the comments below. Thanks for watching, and see you again soon.